Introduction to the Siglent Oscilloscope, Part B. For this part, we will be using two function generators and the Siglent Oscilloscope. Using a BNC cable, connect one of the function generators to channel 1. Don't forget to push in and turn to make a good connection. Connect the other function generator to channel 2. Turn on the oscilloscope. Turn on the channel 1 function generator. Select sine wave and adjust the output to about halfway. Choose a frequency somewhere between 3 and 500 Hz. Using the vertical and the horizontal adjust knobs, adjust the signal so that a few waves are displayed and it covers less than half the screen vertically. By using the ground adjust knob, position the signal in the top half of the oscilloscope screen. Turn on the second function generator. Choose a frequency that is somewhat near but not exactly the frequency of the other function generator. Also, make sure it's a sine wave and that the output is about halfway. Turn on channel 2 by pressing the number 2 button. Using the horizontal and vertical adjusts, adjust it so that it occupies a little less than half the screen, and then with the ground adjust, move your signal to the bottom half of the screen. Notice that the second signal is not stationary on the oscilloscope display. This is because the display is being redrawn every time the first signal is in the same position. But since the second signal is at a different frequency, it is not going to be in the same position every time the first signal is. If we want to see both signals stationary at the same time, we can push the Run Stop button. You might have to push it twice. It is no longer showing you the signal as it's coming in from the function generators. It has merely taken a snapshot in time. I can turn it on and off several times in a row. Notice that each time I stop it, the second signal is drawn in a different location than it was the time before. Now I will run the display again. Press the trigger button to draw up the trigger menu. Next, push the source button. Keep pushing until channel 2 is selected. Now you'll see that the channel 2 signal is stationary on the display and the channel 1 signal is moving around. I can select one more signal. I can push it on external. Then we can input a signal here and trigger the drawing externally. I can change the triggering source again to AC line, and then the drawing of the display will be triggered by basically the wall plug from PG&E. I'll put it back on channel 1 now. In between the 1 and the 2 is a button called the Math button. Go ahead and push the Math button. You will see a third signal appear between the other two signals. This is a result of a mathematical operation between two source signals. By default, the operation is addition. But if we keep pushing this button over here, we can select a number of other operations, including multiplication and subtraction and so on. We're going to stick with addition. The two things added together are chosen here on source 1 and source 2. Notice by default they're both set to channel 1. We'd like one of them to be channel 1 and the other one to be channel 2. So, using this button here for source 2, I'll push it a couple times to select channel 2. Notice that the result of adding these two waves together gives you this ever-changing signal. To better understand this signal, let's change the time scale, the horizontal display scale, to show many waves all at once. The reason for this odd shape is because the two waves are at slightly different frequencies, and sometimes their peaks align with each other, and sometimes they anti-align. So when they align, we get a big signal. When they anti-align, we get a small signal. If this was the addition of two sound waves, the result would sound like wow, wow, wow. This is called a beat frequency. You'll learn more about this in Physics 4C. A beat frequency happens whenever two signals being added together are near each other in frequency. I'm going to adjust the two frequencies so that they're closer to each other in value. Notice, as I make the values closer to each other, the beat gets longer. Using the beat frequency is how professional piano tuners tune their pianos. Now I'll use the math button to turn off the math function. And I'll adjust the horizontal display so that I again have just a few waves of each signal being shown. Now come over here and push the acquire button. Now you get a whole nother menu. Push this button right here to set X, Y on. Now instead of graphing two different signals against time, we're now graphing the voltage value of one signal versus the voltage value of the other signal. The zero ground levels for these two signals are these two triangles. You can use the ground adjust knobs to move the signal to the center of the screen. Try and adjust the two frequencies so that they're as close to each other as you can get them. If you can get them to be the same value, you'll get a stationary oval figure. This is one of what are called Lishizhu figures. Try some other ratios of frequencies, like 2 to 1, for example 300 to 600, or even a 2 to 3 ratio or a 3 to 5 ratio.